Topic 2 in Workshop Statistics is entitled Data and Distributions. A distribution of a variable shows the values that the variable takes on and its frequency. One way to examine the distribution of a set of data is to create a graph, which also leads us to a fundamental principle of data analysis. Start any analysis by looking at a graph of the data. In Activity 2.4 of Workshop Statistics, you'll look at data from the National Highway Traffic Safety Administration. In 2005, data was collected for residents in each state who regularly wear a seatbelt in a car, and also whether the state they live in has a primary or secondary type of seatbelt law. A primary law means motorists can be stopped based solely on seatbelt usage, whereas a secondary law means that the motorist can be stopped only for another reason. The 2005 data appears in the file called Seatbelt Usage 05. We'll look at a graph of the categorical variable law type. Since it's a categorical variable, the default graph in Fathom is a bar chart. In describing the distribution of a categorical variable, we want to discuss the categories of the variable, in this case none, primary, and secondary, and how often they occur. Notice that the frequencies are given as counts, but it's often more helpful with categorical variable to look at the frequencies in proportions or percents. To do that, I'm going to double click on the formula count, and I'd like to change it to column proportion. I'll show you how I'll do that. Under the Fathom editor, click on Special, and that will give you a drop-down menu, and I'm going to go to column proportion and double click, and then I'll say OK. If I put my mouse on the bar secondary, I should notice in the lower left-hand corner, down here is where you'll notice it, that it tells me that there are 28 cases classified as secondary, and that is 56% of our data set. So 56% of the states have a secondary seatbelt law. Likewise, primary, I see that 42% of the states have a primary seatbelt law, and it looks like about 2%, a little less than 2%, have no seatbelt law. In describing the distribution of seatbelt law types in the United States, we might say, in 2005, only 2% of the states in the U.S. did not have a seatbelt law. Of the states with a seatbelt law, the majority had a secondary law, meaning that the motorist could only be stopped for another reason, while 42% of the states had a primary law, meaning that motorists could be stopped solely because they were not wearing a seatbelt. For a single quantitative variable such as a state's compliance percentage with the seatbelt laws, we want to describe the relative center of the data, in other words, a typical value for that quantitative variable. How much spread is in the data? Is there a lot of variability, a little bit of variability? The general shape of the data, and any outliers, gaps, or other unusual features. We often use the acronym SOX to help remind us of the features that we want to describe for a single quantitative variable. Shape, outliers, center, and spread, and always in the context of the data. Some fairly common shapes are skewed to the left, bell-shaped or unimodal and symmetric, skewed to the right, uniform, and bimodal. Notice that the distributions that are skewed either to the left or the right, an easy way to remember it is the skewness follows the tail. So the tail of the distribution here is on the left-hand side, on this side is on the right-hand side. A bell-shaped or unimodal distribution could not be described just as symmetric, because a uniform distribution is also symmetric, as are many others. So a distribution like this I would describe as either bell-shaped or unimodal and symmetric. Uniform distributions, all the values take on approximately the same frequency. And here this distribution, which appears to have two separate peaks, makes us think about perhaps there's something going on in the data set, some sort of categorical variable that I might want to break my data down by to get better overall information about the data set. If asked to describe the distribution of seatbelt compliance percentage, here's a possible description. The distribution of the percentage of motorists that comply with seatbelt laws in the 49 states that have either a primary or secondary law is centered at about 80% compliance, with a good deal of variability among the states, from a low of about 60% compliance to a high of about 95% seatbelt usage compliance. The distribution is skewed slightly to the left because of the state with 60% compliance. However, this data does not appear to be an outlier. Another way to compare the compliance percentage for the different states in the U.S. by type of law is to take the categorical variable law type and put it on the vertical axis of the graph. Now we notice that compliance percentage, let me open this up a little bit, is split by the type of law, secondary, primary, or none. Since it doesn't make sense to comply or not comply when there is no law, I'm going to put a filter on this graph that takes that out. So I'm going to right click to bring up the formula editor, and I'm going to put add filter. I want to filter the data, so I'm going to go up to the attributes, and the attribute I want to filter on is law type, and I will say law type not equal to. So to get not equal to, I'll hold my control key down to make the equal and not equal to, and I want it to look in the categorical variable law type and take out any that have the word none in it, and I'll hit OK. And now I notice that's off there, which is what I want because it doesn't make sense to put it on there. If we're asked to compare the compliance percentage for states that have a secondary seatbelt law versus those that have a primary seatbelt law, here's a possible comparison. States with a primary seatbelt law tend to have higher compliance, about 86% compared to about 76% for states with secondary laws. There is less variability in compliance for states with a primary seatbelt law than with a secondary seatbelt law. The distribution of compliance percentage for states with a primary law is skewed slightly to the left, while the shape for states with a secondary law appears to be skewed slightly to the right because of the two states with compliance percentages around 95%, values that may possibly be outliers. When comparing two or more quantitative distributions broken down by a categorical variable, such as the quantitative variable compliance percentage broken down by the categorical variable type of seatbelt law, you must use comparative words such as more than, less than, about the same. Simply listing the features, center, shape, spread, unusual features such as outliers of each distribution is not considered a comparison of the distributions and will earn 0 points on the AP exam or on any class assessments. In other words, a laundry list of socks for each of the distributions is a no-go and will earn 0 credit. When describing any distribution, avoid using pronouns. Also, avoid using such descriptions as the graph, the data. Instead, use variable descriptions that match the context of the data, such as the center of typical compliance percentage for states with a primary seatbelt law is about 86%.